Hello, today we are talking about composite figures and finding the surface area and volume of those. Now, composite figures simply means we've got two or more different solids put together to create a new solid. So we're going to use what we know about surface area and volume of those things to come up with the surface area and volume of a new shape. So starting with what's labeled as problem 4, we have this lunchbox type solid at the right, and we're trying to approximate the volume of this lunchbox. So what we have in problem 29 is it says it's broken it down into its two shapes. So the top shape right here is the cylinder. It's actually half of a cylinder, and that's drawn right here. So we need to label what we can about the cylinder. So looking at our cylinder all the way across here that I have labeled in black, that's over here in my picture going to match up with this that I've labeled in black, which should be the same as this. So right here is 6, and then I have this other piece that they're asking me to label, which is really the radius of this circle. I want to go to the composite figure that's right here, and that is 3. So that should make sense with the 6 being the bottom, because right now that bottom is the diameter of that circle. The next thing I need to label is across here, and that is going to be this part where the latch is on my lunchbox, which should be the same as 10 at the bottom. So this is going to be 10. So moving on to the prism shape of the lunchbox, I'm going to label what I have here. So starting with the bottom front, that will be the bottom front, which is going to be 10. Then I have sort of the bottom side, which is right here, and that's going to be 6. Then I have the edge at the right side, which is going to be the edge at the right side here, which is 6. So when you're dealing with composite figures, it's really important to draw these two things out and label what you can. So let's go ahead and look at part 30. Find the volume of the top. Well, the top is our cylinder, so when it says the top, we're talking about this part. And so we have the volume formula right here. Now, we start with the volume of a cylinder, and if you look on your formula sheet, the volume of a cylinder is pi r squared h. The thing is, though, I don't have the whole cylinder. I have half the cylinder, which is why I'm going to take my pi r squared h and I'm going to multiply it by 1/2. So let's go ahead and fill in what we know. We have 1/2 pi times the radius squared. And if I look up here, my radius is 3. And then I'm going to multiply that by the height of the prism. Again, that's the height of the prism. It's the distance between the two bases, and that is my 10. And now I should be able to work that out using my calculator. So I have 9 times 10, and then divide by 2, and then times pi. And I will end up with 45 pi. And I'm just going to leave the pi right there. And those are inches cubed. Next thing, I'm trying to find the volume of the bottom. So now I'm talking about this prism right here. And the volume of a prism is base times height. Do I need to do any adjustments to this prism? Do I have only part of the prism? No, this one's actually good. This is the entire prism, so it's going to be the area of the base times the height. So let's talk about the area of the base. The area of the base is going to be 10, which is this part, times the width, 6. So that's the area of the base that I have written down so far. Then I need to multiply that by the height of the prism, and the height of the prism is 6. So I'm going to go ahead and multiply those together, and when I multiply those together, I get 360 cubic inches. And then I need to find the sum of these two volumes. So again, the first volume I had was 45 pi. The second volume I had was 360. Now add those two together, and at this point I do need to pick up my calculator. And when I do 45 pi plus 360, I should get 501.371 cubic inches. Now number 33 is just saying, write it down again. It's 501.371 inches cubed. And that's what we get for the volume of this composite figure. If you need to pause the video, please pause the video here. Moving on, I am now going to talk about the surface area of this figure. We're going to ignore the handle, by the way. I didn't mention that before. So we have the two pieces. The first piece I have is a cylinder. So I'm going to look on my formula sheet for the surface area of a cylinder. And when I look on my formula sheet, I get 2 pi r squared plus 2 pi rh. So that's the surface area of a cylinder. But do I need the surface area of the whole cylinder? No, I only have half of the cylinder. So we only want half of that. So I'm going to do this one by actually calculating the surface area of the whole cylinder, and then I'm going to divide that by 2. So let's start with the surface area of the cylinder. And that's going to be 2 pi, and my radius, and again you should probably still have this on your paper, is 3. So my radius is 3, so 2 pi 3 squared plus 2 pi, again my radius is 3. And then the height of my cylinder was 10. So this is what I have for the surface area of the cylinder. I'm going to simplify that, and I have 9 times 2, so I have 18 pi plus 30 times 2, 60 pi, and that gives me 78 pi, and our units are inches squared. And again, that's the whole cylinder. I don't want that. I want the surface area of half of the cylinder. So I'm going to take that and divide it by 2, and 78 divided by 2 is 39. So this is what I want to use, is the surface area of half the cylinder is 39 pi. Now I need to deal with the surface area of the prism. I don't want all the parts though. This is where it's going to get a little tricky. I want the front, yes. I want the side, sorry, well, I want the front, and do I want the back? Yes. So I'm going to have a front and a back. I want the right side, but I also want the left side. We can't see it, so I'm going to need 2 of those. I need the bottom. I need to include that in my surface area, but do I need to include the top of my prism that's right here? And it's hidden. It's not exposed, so I don't need to use the top. So basically what I want to do is I want to do the front and the back. So that's 2 of the same shape, that rectangle in the front. I need to do the left and the right, and that again is 2 of the same shape, the rectangle on the right, that's 6 by 6, and then I want to add in the area of the bottom. So this is what I need to find. So I have a front and a back, so I'm going to have 2 of these things, and the front dimensions are 10 by 6. So the front dimensions, again, the front is right here. You can see me kind of coloring it in, is 10 by 6. Then I need to add in the left and the right. And again, I have 2 of those, and the dimensions for the left and the right are 6 by 6. So 6 by 6. Then I need to add in the bottom, and the bottom is 10 by 6. So I'm going to calculate each of these, and I'm going to add them all up together. So when I calculate these, I'm going to have, this is 120, this one's 72, and then this one over here, that last one is 60. Adding that all up gives me 252 inches squared. So that's for my prism. Now I need to add them together. So my total surface area is going to be my cylinder, 39 pi, plus my prism, 252, and I can pick up my calculator and do 39 pi plus 252, and I get 374.522 inches squared. So that's how we find the volume and the surface area of a composite function. So again, be sure you have your calculator and your formula sheet because you're about to try one. Moving on to the next page. This one is the one I want you to try. And first of all, what I want you to do is I want you to find the volume of this figure first. Okay, so right now I want you to pause the video and find the volume of this figure. So pause the video now, please. Now, this is not the answer. What I wanted to be sure of before you started, if you already finished, then just let me get through this, is that the radius of our cylinder is 6, the height of the cylinder is 6, and the diameter of the cylinder is 12. So I've kind of drawn that out for you. So if you did not have that and you were stuck on your volume of your cylinder, I would like for you to pause the video now and try and complete the volume of this whole figure, please. So pause the video now, please. Here is my answer, and my answer for the total volume is 1,131.292 cubic inches. If you did not get that, please pause the video here and correct your work. Write down the work wherever you are, write down questions as needed. I'm moving on to surface area. So, I also wanted you to try to find the surface area of this. So please do so now. Pause your video, please. So my total surface area is 694.194 inches squared. The surface area of my half cylinder was 72 pi inches squared, and the surface area of the exposed part of the prism was 468 inches squared. So if you need to correct anything, write down any questions, or write down any work, please pause the video here. Otherwise, I am moving on to the next one. So now we have another composite figure. This one's a little difficult to see. We have a pyramid on top of a prism. So we just have a different shape. Before we had a cylinder and a prism, and now we have a pyramid and a prism. So we're going to start out by finding the volume. So I need to start with how to find the volume of a pyramid. And the volume of a pyramid, look at your formula sheet, is 1/3 capital B H. Now looking at my pyramid, I don't need to add any volume to it or subtract any volume from it. When I find the volume of the pyramid, that's the part that I need. So let's talk about what I know about my pyramid. So capital B is the area of the base of my pyramid, and the base of my pyramid is a rectangle. No, it's a square. So each of these is 3, which means the area of my base is going to be 3 times 3, which is 9 centimeters squared. Then I need the height of my pyramid, and I believe that's actually in here, although difficult to see again. The height of my pyramid is 2. So I can go ahead right now and find the volume of my pyramid. So it's 1/3 area of the base, which I found to be 9, times the height of the pyramid, which was given to me as 2. And when I work that out, that gives me a total of 6 centimeters squared. So that's the volume of the top, the pyramid. Next, I need to find the volume of the prism. And again, with this prism, I don't need to take away any volume and I don't need to add any volume. It is just exactly what it is. And actually, this prism is a cube, so the volume of a prism is length times width times height. And in this case, it is going to be 3 by 3 by 3. So my volume will be 3 cubed, which is going to be 27 centimeters squared. So now I can find my total surface area. So my total volume. My total volume is going to be 6 plus 27. And I apologize, all my units are wrong. This should be centimeters cubed, and this should be centimeters cubed. And when I add these two together, I get 33 centimeters cubed is the total volume of this composite figure. If you need time to write that down, please pause your video now. Now we're going to go on to the surface area. So for the surface area, I know how to deal with my prism. I dealt with my prism before in the last 2 that we did. I know I need to exclude the top of this prism. However, with the pyramid, what I need for the surface area of the pyramid, I don't want the bottom, because the bottom is not exposed. And what do I actually call the bottom of the pyramid? I actually call that the base. And we actually write it as a capital B on our formula sheet. So when I don't want the base, this is called lateral area. So you can either subtract out the base from the surface area or use the lateral area formula. So when you go to your pyramid and you look at when you go to your formula sheet, go to the pyramid and you find the lateral area formula. It's 1/2 LP. So I need to find the slant height and I need to find the perimeter of the base. So let's go ahead and start with my slant height. I'm going to draw my triangle in my picture, although it's going to be difficult to see. I know that this is 2. I know this is my slant height. And this little guy right here should be half of 3. So that should be 1.5. I'm going to draw that out though. It's a little difficult to see. So I have L, I have a 2, and I have a 1.5. So I'm just using Pythagorean theorem at this point. So I have 2 squared plus 1.5 squared equals L squared. And I'm going to work that out on my calculator. I get 6.25 is L squared. And so L is the square root of 6.25. And if I work that out on my calculator, I get that L is 2.5. So I have L is 2.5. Next thing that I need is I need P, which is the perimeter of the base of the pyramid. I'm going to erase what I have on my prism, my solid. And now what I want is the perimeter. This segment is 3, this segment is 3, this segment is 3, and this segment is 3. So the perimeter should be 3 plus 3 plus 3 plus 3, or 4 3's, which should be 12. So I know that my P is 12. So we can go ahead now and find my lateral area of my pyramid. So I have 1/2 times 2.5 times 12. Sorry, I'm not using my colors. 2.5 times 12. So I can pick up my calculator and I can work this out. This gives me a lateral area of 15, I believe, centimeters squared. So now I need to deal with my prism. So for my prism, let's figure out what parts I need. This one's a cube, actually, so it's actually very easy. In a cube, all the faces are the same, and there's a total of 6, I believe. The front, the back, the left, the right, the bottom, and the top would make 6, but I only want 5 of those faces. So I need 5 of these faces, and I know the dimensions of each face is 3 by 3. So I know this area of each face is 9. So my prism is going to be 5 times my 9 centimeters squared, which should give me 45 centimeters squared. And if you want to work it out the way we worked it out the other ones, you're absolutely welcome to do that. So now I should have my total surface area. And my total surface area is going to be 15, my pyramid, plus 45. And when I add that together, I get 60 centimeters squared. So please bring any questions that you have to class, and I hope you have a wonderful evening.